In today's video, we are going to look at graphing inequalities. And so that is what your learning target is today, is to graph a linear inequality with two variables. So in previous lessons, you learned that a one variable inequality can have infinitely many solutions, and that these solutions can be represented on a number line. But what if an inequality has two variables? What is the solution to a two variable inequality? And how could these solutions be represented graphically? So those are the questions that we're going to be thinking about as we go through these problems. So graphing a two variable linear inequality. Graphing a linear inequality is so easy because it is basically the same as graphing just a regular linear equation, but there are a couple of rules that we have to think about. And so first, you want to graph the line as you know how to graph a linear equation. And so if I have, oh my goodness, where it is, there it is. If I have, this is my slope, and this is my y-intercept. And so I'm going to start at -1. And my slope is rise over run. So I go up 2 over 1, up 2 over 1, and I keep going. I can also go down to left 1 in the opposite direction. Okay, so I did step 1. Step 2, this is something new that we have to consider. Is it a dotted or a solid line? And it depends on the symbol that we have. And so just like when we were graphing on a number line and we either had an open circle for less than or greater than and a closed circle for less than or equal to or greater than or equal to, we're going to have the same thing with this inequality, except now we're looking at the line. And so if it is a less than or greater than, you are going to have a dashed line. If you have a greater than or equal to or less than or equal to, you're going to have a solid line. So with this symbol, what do you think we're going to have? And it is a dashed line. Okay, so we did step 2. Step 3 is shading, because on a linear line equation, the solutions are just on the line. But with an inequality, there isn't just one certain solution. There are many, infinitely many solutions. And so we have to figure out, are the solutions over here on this side of the linear inequality, or is it all over here in this side of the linear inequality? And also it's dependent on the symbol. And so since y is greater than, you want to go to your y-intercept, which is right here, and you want to shade everywhere where it's greater than y is equal to -1. So you're going to shade all these y values, which means you shade this whole side of the graph. That is how you graph a two variable linear inequality. There's another way. Instead of just shading, or instead of just going to the y-intercept and shading either above or below, you can also test a point. I'm going to test the point 0, 0 is always the easiest to test, unless of course your line is going through 0, 0. But if I plug in 0, 2 times 0 for x and y, is 0 greater than -1? If it's true, that means that point is a solution and you would shade on this side. If it's not true, you would shade the other side. And let me do a quick example. Let me change the color on that. Let's say I picked 2, 0. Okay, so if I plug in 2, 0 into my original equation, is 0 greater than 3? And it's not. So therefore, I would know my solution isn't on this side. And so you have an option of whether you want to, I prefer just going to my y-intercept, and since it says greater than, I'm going to shade above. But if that's confusing to you, then you can always test a point as well. let's go ahead and try the next example. Y is less than negative a half x plus 4. The first step is to graph this as we know how to graph a linear equation. So I start at 4 on my y-axis. My slope is negative a half. That means I go down 1 over 2, because again, slope is rise over run. And in this case, my slope is negative 1/2. So I'm going to go down 1, the negative, and positive 2. Negative 1, positive 2. I can also go positive 1, negative 2. Okay, so that's my first step. Second step, am I going to do a dashed or a solid line? Well, since it's less than, and there's no equal to under here, I'm going to do another dashed line. Sometimes I call it dashed. When I made this PowerPoint, I obviously called it dotted, but same thing. And now I need to know where I'm going to shade, okay? So I'm going to look at, this is less than, so I'm going to go to my y-intercept, and I'm going to shade everywhere less than my y-intercept of 4, which is all of this. So my shading is under here. If you would prefer to test a point, sure, let's do that. 0, 0 is always easiest to test if you can. If I plug in 0, negative a half times 0, 0 plus 4, is 0 less than 4? And because it is, 0, 0 is a solution, so I shade here. The solution to this inequality is this entire shaded region, and it keeps going to negative infinity on the y-axis, negative and positive on the x-axis. Okay, so that is how we graph a linear inequality. Let's try again, but this time with no steps written out. I've got y is greater than or equal to negative 1/3 x minus 2. Let's begin. I start at negative 2. I make a point here. My slope, rise over run, is equal to negative 1/3, which is the same thing as 1 over negative 3. So I'm going to go to my y-intercept. My slope is negative 1, run 3, down 1, 3. It's also the same thing as positive 1, negative 3. Okay, next, is it going to be a solid or a dashed line? Well, in this case, I do have an equal sign too. And if you have trouble remembering, this is my trick. If it has a solid line, it will be a solid line. If it has no solid line in the symbol, it will not be a solid line. It's pretty good, right? And so now I'm going to have to shade, because if this was an equation, right, my solutions are along the line. But because this is an inequality, I have infinitely many more solutions, not just on the line. So since it's greater than, I'm going to go to my y-intercept, and I'm going to shade everywhere greater than negative 2 on my y-intercept. So that's why I'm shading all of this. Okay. And so again, if you want to test a point, let's try it out. I'll test 0, 0, or let's check something else. Let's do this one. Let's do 0, negative 3. 0 times that minus 2. Is negative 3 greater than or equal to negative 2? Because it's not, this is not a solution. Therefore, I know not to shade here, which means I'm going to shade on this side. To be thorough, you can check another point over here if you want to. Okay, but typically we would know if it's not on one side, then it must be on the other side. Now, this is where I give you a little reminder to check your work. We all make mistakes, so you can check your work by testing a point. And I already explained this. You want to choose a point on either side of the line. Try to pick 0, 0 if you can. Let me write that in, 0, 0. Is the remaining inequality true? If it is, then you shade there. If not, you shade on the other side. So I'm giving you an option. Some teachers will require you to test a point. I really don't mind if you don't test a point. All right, let's try our last example. Try this on your own. Now, I will say your homework is not going to be as simple as these where it's already in slope intercept form. You might receive something where you got to move some things over to get it in slope intercept form. So let's try this one right here. It's difficult to graph this right away. So I'm going to change it to slope intercept form. I'm going to subtract 2x from both sides. I've got negative y is less than or equal to negative 2x plus 5. I need y by itself, so I'm going to divide both sides by negative 1. What happens if I divide by negative 1 or a negative number? It's going to change. We need to flip our sign. And so it goes y, it now becomes greater than or equal to 2x minus 5. Okay, do not forget that part. When you multiply or divide by a negative number, you must flip the sign. Now it's in slope intercept form, so I'm going to start graphing. It looks like I start at negative 5. And my slope is 2. So I'm going to rise up 2, run 1. And I'm going to do a few of these just to help me make my line straighter. You do not have to do every single point on your graph. But if I don't, my line will be super wobbly. Okay, now is it a solid or a dashed line? Well, I have a solid line in my inequality symbol, so I know it's going to be a solid line. Use a ruler when you're doing this stuff to be more accurate. Me on my little tablet, not so accurate. And now where am I going to shade, above or below? So looking at this equation, don't look at this one, right? Because if you shade depending on this symbol, you're not going to be right, because y is actually greater than. And so I'm going to go to my y-intercept, which is here, and I'm going to shade everywhere where it's greater than the negative 5, which is all over here. And that's how you graph a linear inequality with two variables. As always, you can test a point if you want. 0, 0, easy peasy. 0 times 2 is 0, minus 0 is 0. Is 0 less than or equal to 5? And it is. So that's the solution. So all of that is solution to this linear inequality. So that is it. I hope this lesson was okay, as long as you know how to already graph a linear equation. Graphing a linear inequality just has 2 extra steps in order to complete it.